Welcome back to SBR channel. Today we are going to take the lab session in which we are going to discuss about the IV characteristics of ZENER diode. We are going to draw the IV characteristics of ZENER diode as well as we have to note down the breakdown voltage of the ZENER diode. And what we needed the apparatus? We needed the ZENER diode. This is our ZENER diode. This is our ZENER diode. In that, if we are going to observe here, one black ring is there. This black ring indicates that the negative terminal of ZENER diode, and another terminal is positive terminal, which is the anode, and black ring is cathode terminal. Then we need it that 1N758A or 1N962B. We need it one power supply. This is our power supply. We need it power supply minimum 0 to 15 volt. I have selected today here it is 0 to 12 volt. Then this power supply we have to use with the potential divider. Next we need it here microammeter. Instead of microammeter I am going to use here milliammeter is there. It's ranging from 0 to 50 milliampere. We needed the voltmeter. It's ranging from 0 to 15 volt. Then one resistance also we are using. Its value is nearly. If you are observing here, here it is black color, brown color, black color, and brown color, and here it is gold strip is there. Then if I will find out by using the color coding, this resistance is nearly 101 ohm. We need it minimum 100 ohm for this ZENER diode 1N758A. Then we need it for connecting wires. Then what is the principle of our experiment? We are going to find out IV characteristics of the ZENER diode. Then ZENER diode is a one special type of the PN junction diode which will conduct in the reverse biasing. For that sake, that in reverse biasing what it is conducting based on that principle is here it is. ZENER diode in reverse bias, after certain voltage, the current suddenly increases after the breakdown voltage. The current is constant even though the current varies over a wide range due to a internal penetration. Then now you see here it is circuit diagram is there. We need to connect the circuit diagram. Then if you are observing in the diagram, there is battery. In that battery, this one is positive terminal, this one is negative terminal. Positive of this battery connected to the rheostat. Which is rheostat here it is. This is our rheostat. Then we are connecting rheostat. There are three terminals. These two are the base terminals, and this one is upper one is the variable terminal. Then we need to connect positive of the battery to the base of the rheostat. Then this is our positive terminal. This red color is positive terminal, and red color is positive terminal, black color is negative terminal. Then this red color we have to connect one of the base of the rheostat. Then from this same terminal base, one more wire it connected to the positive of the milliammeter. If you are observing here, positive are connected to this base, and from this base only I have connected here positive of this milliammeter. Then we should come across this negative of the battery. Negative of the battery connected to the plug key. Then this is our negative of the battery that I have connected to the plug key, one of the terminal. Then from another terminal of this plug key, it goes to the another terminal of the rheostat. This is our another terminal. This goes to the another terminal of this rheostat. And next you come towards negative of the milliammeter. The negative of the milliammeter connected to the negative of the ZENER diode. This one is our negative terminal. This is negative. This one is positive terminal. Then negative of this milliammeter connected to negative of the milliammeter connected to the ZENER diode, which is the negative terminal. This negative of this milliammeter, which is this negative terminal, it connected to the negative of this Zener diode. This is negative terminal of the Zener diode, which is the black ring. Then from this same terminal, we have to connect to the positive of the voltmeter. Then here I have taken one wire from the same terminal, which is connected to this positive of this voltmeter. Then you come across the negative of this voltmeter. Negative goes to the one of the resistance, and from this resistance, one more wire you have to connect to the variable terminal. Then from this positive of the negative of the voltmeter, it goes to the one of the resistance, and from this resistance it goes to the variable terminal. Then next you come across the another terminal of this resistance, which is of 100 ohm, which is of 100 ohm. Then from this another terminal you have to connect to the positive of the diode. Then another terminal you have to connect to the positive of this diode. After connecting this, we have to check it that our Zener diode is in the reverse bias. What is the meaning of reverse bias? Positive of the battery connected to the negative of the Zener diode, means it is connected to the cathode terminal. Then I want to take the now trials. For that sake, we have to observe the here some things in our apparatus. We need to make the observations. If you are observing here, this is my voltmeter 0 to 15. It is calibrated. Then in that, I have to find out the observations. Least count of this voltmeter if I want to find out here. You observe here now 0 to 2.5. Here 10 lines are there. Then I need to find out the least count of this, means 0 to 2.5, 10 lines are there, then 2.5 divided by 10. If I want to fill up this, I am getting here it is 2.5 divided by 10. Then this value I am getting here 0.25 volt. Means least count of this voltmeter is 0.25. If I want to find out the least count of this milliammeter, you observe this our milliammeter, which is from 0 to 50 milliamp. Then it is also calibrated into 10 lines, 0 to 10. Then if I am going to find out the least count of this milliammeter, I have to take here milliammeter, it is calibrated into 10 lines, in between 10 divisions are there. Then if I will divide this, I am getting each line value means 1 milliampere, which is nothing but the least count, which is nothing but the least count of this milliammeter. Now let us observe now, if I will switch on the battery, then if I will switch on this battery here, then current is not flowing through my circuit. If I want to pass the current through the diode, I have to close this plug key. If I will close the plug key, then also I am not getting the current flowing through this our circuit. Then what I should do now here, step by step, I have to vary the voltage which is flowing through our Zener diode. Then it will be conduct up to its breakdown voltage. Then if I am going to show here, you observe now this tabular column. What I show to you, if I am going to vary the voltmeter value 0 to up to 1 volt, I am getting the reading in milliammeter as a 0. It will not show any deflection in the milliammeter till 1 volt. Whenever I am going to increase beyond 1 volt, in the range of 1 volt, then slightly my milliammeter will show here some readings that I will note down here as per this tabular column. Then at a one particular step means if I will go on increasing the voltages in the range of 1 volt, I will get it 0, then 2 volt. For that I will note down the milliammeter reading as a 4 milliampere, then 3 volt, 3 volt, I will get it the 8 milliampere. In this way, up to a particular voltage, as I will increase the voltages in the linearly, I will get it the increase in the current also linearly. Current will increase linearly with the voltage. But at one particular voltage beyond 8 volt, if I am going to increase in the range of 1 volt, instead of that, I will increase slight increase in the voltage means 0.25 volt. Also if I increase the here, I will get it the sudden increase in the current from 26 milliampere I will get it the current is flowing through my milliammeter is 50 milliampere. It means that my ZENER diode is breaking its voltage at one particular value where I am getting the sudden increase in the current. That means ZENER diode is a one special type of a diode that because of the at particular voltage that a diode will be breaks its voltage at that step covalent bond what formation takes place, it will be breaks, and at that time sudden increase in the current takes place because that barrier voltage it will be very small, and because of the high electric field what it is flowing through the diode, because of strong electric field that covalent bonds will be breaks, because of that what happens here, sudden increase in current takes place at that voltage where we are getting the sudden increase in the current, that voltage is called as here breakdown voltage. Then I will show to you at which voltage our ZENER diode will be breaks down. Today I have selected here 1N758A ZENER diode whose breakdown voltage is nearly equal to 8.2 around or 8 to 8.5. I will get it that value. Then step by step I will show here, just to observe here. And one more component here it is there, resistance. We have to use resistance of 100 ohm to save our diode. It should not be damaged beyond the breakdown voltage. If I will increase the voltage, my diode will not be break, my diode will not be damaged after the breakdown voltage also. It means that it is one special type of a PN junction diode which is manufactured by CA ZENER by heavily doping. Because of that heavily doping after the breakdown voltage also, if I am going increase, if I am going to increase the voltage, then my diode will not be damaged. Then recombination of the hole and electron pair takes place beyond the breakdown voltage, and in this way I can save my diode by damaging that diode. Just to observe here it is, I will show to you step by step here. I will switch on the battery, then slowly I will increase here voltage. This is 0 volt and here is also 0 current. Slowly I will take first line means 0.25 volt. There is no current flowing through my circuit. Next one 0.50. Then also my needle is not deflecting. 0.75, there is no deflection. Then whenever I will come across 1 volt, here are 4 lines means 1 volt, then also my needle is on the 0 reading only. Then 1.25 onwards I will get it slight increase in the current. Here I am getting here 1 milliampere. If I will take it here 1.25, 1.5, linearly it increases now here. If you are going to observe now here slowly, if I will take on the 2 volt, here are 8 lines, 8 lines means 2 volt, then my milliammeter is showing here 4 milliampere. For 2 volt I am getting the 4 milliampere reading. Like this, if I have taken on 3 milliampere, slowly I will get it the increase in current. If I will increase this is 2.5, 2.75, then this one is 3 milliampere. Here I am getting the 8 volt. For 3 milliampere, for 3 volt, I am getting the 8 milliampere current. In this way, if I will increase in the step of 3, 4, 5, 6, 7 up to 8 volt, I will get it the linear increase in the current also. That I will show here how it is increases up to 8 volt. Slowly, if I will increase this, you observe here voltage is increasing linearly, current is also increasing linearly up to 7.5 volt. I will go. Then slowly after 7.5 volt, I am getting here for 7.5 volt as a 24 milliampere. If I have taken 7.75, it is showing here as a again 25. 7.75 8 volt. For 8 volt it is showing here 26 milli. Then after that 8.25 27 milli. 8 point, then suddenly now here it is increases from 25 milli to 39 milliampere. When I increased by 0.25, just only from 8 to 8.25, suddenly my needle is deflecting from 26 to 40 milliampere. In this way, if I will increase by 25 centimeter again, then 25.25 volt again, then sudden increase in the current takes place. In this way, beyond the limit also, if I am going to increase the voltage, that my diode will not be damaged. I can show to you reverse. If I will go back again, then again I will get it the characteristics of this diode. It means that Zener diode will be works according to its property beyond up to a particular limit. As voltage is increases linearly, there is linear increase in the current also takes place, but beyond the breakdown voltage, at a one particular voltage of the diode, that a diode will be breaks its voltage, it will be breaks down. And if you are going to observe here, I will show once again here, current sudden increase in the current takes place. In this way, that Zener will be breaks its voltage at a one particular voltage where sudden increase in the current takes place. That voltage is called as here breakdown voltage. Then today I am going to observe here, suddenly voltage increases at 8 point. Instead of this 9, I am getting today here it is 8.50. Suddenly my current increases up to 39. Then next 8 point, only one line if I increases now here, suddenly here if I am going to take 8.50, I am getting sudden increase in my current is 39 from here. Suddenly I am getting here 39 milliampere. Then after that sudden once again increase I will get it here. That's why my Zener diode will be breaks at a voltage 8.50. In this way, if I am going to observe graph, if I will draw the graph, voltage versus current. Voltage if I have taken along the x-axis and current along the y-axis, then what I am getting here, up to 1 volt, there is no increase in the current in the milliammeter. But as I will go on changing from 1 volt to 2 volt, slight increase in the current that takes place in milliammeter. How much it is there? For 2 volt, for 2 volt I am getting, for 2 volt I am getting the current flowing through the milliammeter is 4 milliampere. Then for 2 volt I have drawn here 4 milliampere. For 3 volt again 8 milliampere. In this way, up to 8 volt I am getting the increase in the current linearly. It will be increase up to a 26. It will be increase up to a 26. 8 volt if I will draw across that, current is flowing up to 26 milliampere. But when I will go suddenly, when I will go suddenly at 8 volt to 8.25, then sudden increase in current takes place from just 26 milliampere. I am getting nearly 39 and nearly after that again 50 milliampere. Means at 8.50, if I will write it here, 8.50, 8.50, suddenly current increases. Then then Zener diode breaks at the voltage 8.50. Then what is the breakdown voltage of my Zener diode? It is 8.50. That means we have drawn the IV characteristics of the ZENER diode and we got it the breakdown voltage which is nearly equal to 8.50. Thank you. So